A warm welcome to all from Department of Chemical Engineering, SRMSD Katamulathur. In today's topic, we'll study about filtration. I am Dr. J. Kirtika. I am working as an assistant professor in the Department of Chemical Engineering since 2018. And I have 10 years of experience in teaching. I have graduated from IIT Madras for my full-time PhD. Filtration concepts, principle, mechanism, and equipments will be discussed in this video. The definition of filtration is that it is a removal of solid particles from a fluid by passing the fluid through a filtering medium, septum, or through a porous medium, which helps to retain the solids and allow the liquids to pass through. As we see in the picture, the liquid permeates through the filter medium and the solids are trapped within the filter medium. The liquid which passes through the filter medium is known as filtrate, and the solids which are retained on the filter medium is known as cake. The day-to-day application of filtration includes water purification, brewing of coffee, air filtration, and also separation of the lemon seeds from lemon juice. The filter medium, as I said, it can be made up of a screen, cloth, or a membrane. The solid particles which are trapped within or on the pores of the filter medium is known as cake. The liquid which passes through the medium is known as filtrate. The characteristic of the medium includes retaining of solids to give a clear filtrate, should not plug and bind, should be chemically resistant and mechanically strong to withstand the process conditions, should be corrosion resistant and should be able to discharge the cake easily and cleanly. The medium should be cheap, it should have a long life and offer little resistance to filtration. What are the materials that can be used as a filter medium? So for corrosive liquids, we can use canvas cloth, woolen cloth or metal cloth. But when we have a normal day-to-day applications, we can go for a polymers like nylon, polypropylene for acidic condition and also for polyesters. Filter aid is an external agent which is added to increase the porosity of the cake and to permit the liquor at the reasonable rate, because the resistance offered by the filter medium is very high, and to overcome this situation we add diatomaceous silica, perlite, purified wood cellulose as a filter aid to overcome this defects of increased pressure drop. So methods of using filter aid. So how this filter aid can be added to the process during the filtration. So it can be either mixed to the slurry well before the filtration process so that it offers the characteristics of porosity and it disperses the cake so that the pressure drop is does not affect the filtration. You can also do a pre-coating by depositing a layer of the filter aid on the filter medium before the filtration, such that the medium has a long life and it doesn't clog with respect when the cake is passed through the medium, and it also reduces the pressure drop. So we will see going to see the classification of filtration. So based on the operation, how the filtration process is classified, based on the desired product in the filter, and also based on the driving force and based on the operating cycle and also the mechanism of filtration. Based on the filtration operation, the filtration process can be classified as based on the volume of the suspension and also based on the volume of the solids in the slurry which needs to be filtered. So if we have in the water purification process, so we have to remove a very small amount of the solids from the liquid for getting water for the numerous applications. And similarly, in case of the chemical industries, we would require a very less amount of the liquid with the solids which has to be removed. So based on the volume of suspension to be handled, it can be high or it can be very small with respect to the water. Based on the proportion of solids in the suspension, it can be classified as high, means high amount of solids, less amount of liquids, or very low amount of solids and large amount of liquids to be separated during the filtration process. Based on the desired product in the filtration, like when we do the filtration, whether the liquid is important or the solid is important. So based on the desired product, we can many times we need the liquid or the fluid which passes through the filtrate or the filter medium, or in some case the solids which is deposited on the filter cake also forms a desired product which needs to be recovered and further processed for any other applications. In some case, both the solids and fluid would be needed during the filtration process. In water purification application, we doesn't know we doesn't want the solids we doesn't want the solids or neither the liquids, but we need that solids to be separated from the liquids so that it further treatment process can be carried out. Based on the driving force. So based on the driving force of the filtration, how we can separate the solid from a liquid by using a filter medium. First, this driving force can be a gravity force. So based on the gravity force, when we pour a fluid on the filter medium, the solids can be retained and the liquid can percolate through the filter medium and it can be collected as a filtrate. Or in some cases, when the amount of solid is very much high, we can apply a mechanical pressure so that the solids are retained on the filter medium, leaving the liquid to filtrate. We can use a negative pressure called vacuum pressure from the bottom of the filtration process so that the liquid is percolates through the filter medium. Many times, filtration also works by the principle of a centrifugal force, where the principle of centrifugal force is being applied for centrifugal filtration. Based on the operating cycle. So filtration can also be classified based on the operating cycle, such as batch filtration and continuous filtration. Batch filtration examples include plate and frame plate filters, leaf filters, and continuous filtration operation includes vacuum filters and rotary drum filters. For filtration, it can be classified as cake filtration, deep bed filtration, and cross flow filtration. In cake filtration, the solids are retained on the cake and it can be separated and the liquid filtrate can be collected. In deep bed filtration, the solids are retained inside the filter bed. So it is, as seen in the picture, it can be clogged to the filter bed and the liquids percolates through the filter medium. In the cross flow filtration, when we have a suspension to be filtered, so the suspension flows on the filter medium and there is a negative pressure which is applied, which ensures that the filtration happens in a perpendicular direction to the filter medium. So the name cross flow filtration has been implied. Based on the mechanism of filtration, cake filtration ensures the proportion of solids in the suspension is large and most of the solids are collected above the filter medium as cake. The cake can be removed from the filter medium and it can be processed. And in deep bed filtration, the proportion of solids in the suspension is very small and the particles are smaller than the pores of the filter medium and it will penetrate and it will be retained within the filter medium. No solids will appear on the surface of the filter medium. Examples include water purification. In the cross-flow filtration, when the feed suspension flows under pressure at fairly high velocity across the filter medium, a thin layer of solids may form on the filter medium. A high liquid velocity keeps the layer from building up. The filter medium will be made up of ceramic polymer with pores smaller enough which excludes most of the suspended particle. Some of the liquid passes through the medium as a clear filtrate and more concentrated suspension is left behind. Examples includes ultrafiltration. While understanding the principle of filtration, we need to understand the terms slurry, cake and filter. So slurry is the feed to be handled is known as slurry. The deposited solids on the filter medium is known as cake. The liquid leaving the filter medium is known as filtrate. So as we see in the diagram, so the slurry is fed to the top of the filter medium and the slurry passes through the filter medium and it percolates the filter medium and it is collected as filtrate. The solids in the slurry are retained as cake on the filter medium. Initial filtration results in the formation of particular solids on the surface of the filter medium. During initial flow, the solid particles are trapped within the pores of the medium, forming true filter medium. The liquid passes through the bed of the solids and through the filter medium. Initially, the rate of filtration is high. As the cake thickness increases, the resistance to the flow also increases. The rate of the filtration decreases for a given pressure drop across the medium because the filter cake would have got clogged and it offers resistance to the filtration.
So based on the pressure drop across the filter medium, the filtration is classified as constant pressure filtration and constant rate filtration. In constant pressure filtration, the pressure drop is held constant and the flow rate is allowed to fall with time. So the flow rate decreases with time as the cake accumulates and the pressure drop is held constant. Whereas in constant rate filtration, the flow rate is maintained constant and the pressure drop is progressively increasing. So example of constant pressure filters are screen filters and edge filters, and examples of constant rate filters are positive displacement pump and relief valves. Any filtration operation in a cake filter, it undergoes two resistances in series. One is filter medium resistance, the other is cake resistance. Coming to the classification of filtration equipments based on the nature of filtration. Example, based on the solids which is present in the filter, slurry. So if we have large amount of solids to be removed with a little amount of liquids, then we can offer cake filters. Whereas if we have very small amount of solids as an impurities in the liquid, then we can choose clarifying filters. If the feed is flowing 90-degree to the filter, then we have cross flow filters. Okay, so the speed of suspension flows under pressure at fairly high velocity across the filter medium. So then we need to choose cross flow filters. Based on the application of an external force, the filtration operation is classified as pressure filters, vacuum filters and centrifugal filters. So examples of pressure filter are plate and frame press filters. Vacuum filtration offers leaf filter in the batch process and rotary drum filter in the continuous process. So centrifugal filters are suspended batch centrifuge, and all the laboratory centrifuge operate by the means of centrifugal filtration. Let us just discuss one such example of the filtration with the equipment's principles and operation. So I have chosen leaf filter for a discussion. So as the name suggests, the leaf filter has a leaf-like structures for performing the filtration operation. Here, the external force applied is a vacuum or suction. So from here, so whenever we passes the feed on the filter cloth, so it can be rectangular in shape, it can be circular in shape, or it can be in any desired shape. So once the liquids penetrates inside, it has been suction. Due to the suction, it has been collected as filtrate. Okay, so the solids will be accumulated on the filter cloth, and it can be removed by passing the air in the reverse direction. Leaf filter consists of a longitudinal drainage screen covered with a filter cloth. Vacuum or pressure has been applied to increase the rate of filtration. This filter cloth acts as a stainer and collects the solids. So it can be of any, the frame can be of any shape, circular, rectangular or square, and it is fully covered with the filter cloth. The outlet of the filtrate is connects to the inside of the frame through suction. So this is the description of the filter cloth which we have already seen, and this is the working principle. So the filter leaf is immersed inside the slurry. It can be any equipment from which the filtration has to be performed. So vacuum is connected to the outlet because vacuum is the force by which the filtration happens. The slurry passes through the filter cloth and the filtrate enters the drainage canal and it is collected to the outlet of the receiver, and air is flowed in the reverse direction for the removal of the cake. Here we can use this kind of filtration only if our slurry has 5% of solids. It means only diluted suspensions can be operated with these kind of leaf filters. Advantages: simplest form of filter used in the batch process, a large number of units. Say if you want to multiply this capacity, you can connect a number of filters in parallel to increase the surface area of the filtration. So it can go for high pressure, say up to 800 kilopascal of the vacuum filter or pressure can be applied for filtration. The labor cost is moderately fair, and the efficiency of washing is high. The slurry can be filtered off from any vessel. It means you need not be worried about where is the content which has to be filtered. So anywhere you can install this type of filters and start the filtration operation. The cake can be washed by simply reversing the flow of suction. Disadvantage, as said, only dilute solutions can be filtered in these kind of filters. The design is little complicated and it is expensive, consumes more water, and it can be used for batch operations. Next, coming to the applications, it can be used for metallurgical applications to recover valuable precipitates, used for dilute solutions, for biodiesel production, edible oil refining, and also in sugarcane refining. These type of filters has been used. So the cost of this filter comes up to 50,000 as a minimum to any number, like based on the number of filter cells we have, it can be the filter cost can be added. So these type of filter are simple, handy, and it can be used for filtration at that instant wherever the filtration is required, for specifically used for dilute suspensions. So thank you.